Hello everyone. So I welcome you all in this lecture. Here we would be talking about the kinematics and concepts related to velocity, acceleration and motion in the plane and in the straight line obviously. So the idea of this lecture or this course is that first we will be uh, understanding the basic theory part, and then we will be solving the question of Iit Jee, and then we will increase the level of our theory, and then we will be solving the question asked in higher physics exams like JAM, GATE, CSIR, etc. But here, since this is the very basic topic that is kinematics, so here I will only be talking about the question related to IIT JEE and some of the question of IIT JAM exam. And gradually we will be increasing our pace, and then we will be understanding the theory part which is asked in higher physics exams. And yeah, so let's start this video. So first thing is, we should know what is kinematics, right? Actually there are two kinds of fields. One is called as kinematic and another thing is dynamics. So when we deal with motion, that kind of field is called as kinematics. If we are interested to find the motion of any body which is let's say at time t, it is at a position and then it moves to b position. So how it moves from a to b, and what were the cause of this motion, and what were the phenomena which were happening here while this body was moving from A to B. So that particular things come under the domain of kinematics. If we want to find the motion, if we are interested to find the trajectory of any particular body, that comes under dynamics, which would be covered in the upcoming lectures of Kepler's law or gravitation, I mean. So for understanding kinematics, we should know what is motion, right? Let me clean it. So yeah, you may have been aware about the frame of reference. Frame of reference is nothing but three mutually perpendicular axes which are x, y and z, and from here we choose any arbitrary origins, and then we designate some coordinates to any events which will be happening somewhere from the origin of this frame of reference, right? Say this is any event which is taking place at x, y and z at time t, right? So these are the coordinates of this particular events with respect to this with respect to this origin, right? We have designated the coordinate to this event from this frame of reference. So if these coordinate changes from this point, say this is a point, to this b point, as at time t is equal to t naught, these coordinates are x, y and z, and let's say these coordinate changes to x1, y1 and z1. So the change which is produced in these coordinates while this particle or this event was moving from point A to point B, this is called as motion, right? What is exactly motion? Motion is the change in the coordinates of any particular events or any particular body. So that study of motion comes under kinematics, right? So this is motion, and uh, which we are going to study here in this lecture. So what happens when body moves, when body possesses this motion? Then there are few things which we should know, which are these things. See here, these are the things that we will be covering in this lecture. So firstly, we have understood the motion. What is the motion? Motion is just the change in the coordinates, right, which is produced when body moves from point A to point B. This is termed as motion. So while body is moving from point A to point B, we should be aware about certain terms which are very basic, and I am very sure that you would be aware about these terms. So first thing is displacement. See, let's say this is any frame of reference, and this is any position of particle. So I am assuming that you are aware about certain basic terms like what is position vector, and you know how we play with these vectors like cross product, dot product, and taking the components of these vectors along x-axis, y-axis, and how we subtract or add two or more vectors. So these are the things that you may be aware about. If you are not, just comment and I will make the video about that. So here, say this point P has a position vector which is r1, right? And when this body moves from point A to point B, as I said, it is termed as a motion. So let's say it at point B, this particle has position vector r2. This is at time t2 and this is at a time t1. So yeah, this change in position of this particle P from A to B is termed as displacement. What is displacement? It is nothing but the difference of its final position with initial position, which is generally taken as a positive always, because it is like we would be taking its magnitude and direction as well. And second thing is distance, which you also know that if I am only and only considering the magnitude part, then that comes under the distance, because distance will not have any particular direction, right? So this is the displacement, the change in its final position and its initial position, right? Second thing which comes which is what is the velocity, right? If I am interested in finding the rate of change of this displacement with respect to the time, then that would be termed as velocity. Remember, velocity is the vector quantity unlike speed. So what is velocity? If I am interested in the average velocity, there are two parts. First thing is the average velocity, and second thing is the instantaneous velocity, right? So what is the average velocity? If I am taking the how much there is change in the displacement with time from final position to initial position, that is termed as the average velocity, the change produced in the velocity at the initial position and the final position with time obviously. So what it would be, it would be r2 minus r1, the position vector of these 2 points with time. How much is the difference in this time? So how it would be, it would be delta r upon delta t, right? So this is the average velocity, finding difference between the position, this A position and B position with time obviously. Now if I am only and only interested in finding the position at very small interval of time, that how much is the how much variation is coming in the position in this short interval of time with of that particle, so that would be termed as the its instantaneous velocity, right? If I am interested in finding the change in the position at very small interval of time, then at that particular instant, that velocity would be called as instantaneous velocity, right? Say I am I want to find the variation in uh, how rapidly it is covering the distance at this particular instant with time, then that would be its instantaneous velocity, right? If I want to find how rapidly it is covering the total distance with time, that would be average velocity. And if I am interested in very small portion of this distance, then that would be its instantaneous velocity. Obviously, because I want to find the change for very small interval of time, so I would put its limit towards zero, because time would be very small. Then what will happen when this delta t tends to zero? And then this will become very small or instantaneous. I could write this as dr upon dt. So this is the instantaneous velocity, which we generally consider in most of the derivations and maximum time when we are solving the questions or these kind of things, right? So what is instantaneous velocity? This is dr upon dt, change in the position of particle with time for very small particular instant. So this is instantaneous velocity, right? So this is instantaneous velocity. uh, yeah. Now next thing is the acceleration. So if there is the variation in velocity, the particle's velocity either is increasing or decreasing. If velocity is decreasing, that would be termed as deceleration. But if velocity is increasing with time, that would be called as acceleration, right? So let's say body is moving from point A to point B. At point A, body has a velocity v1, say at particular time t1. And if body, when it arrives here at point B, it has its final velocity v2, and it arrives here at time t2. So how much is the variation which has come in its velocity in this particular interval of time is termed as its acceleration. So as usual, it is a vector quantity and it is what the variation in the velocity with time. Yeah, like velocity, it also has it is also the average and instantaneous part. So if I am considering the net change in velocity in its final position and at its initial position, that would be its average acceleration. But if I want to find the change in its velocity for very small interval of time, where this delta t would more or less tends to zero, if I want to find the change which would have come here in uh, this small interval of time, then that would be termed as instantaneous acceleration. It would be what? It would be, I would have to truncate it with limit. That would be like this delta t which will tends to zero, and then it would obviously become what? dv upon dt. So this is the normally acceleration we write in many equations or while solving the problems, right? So this is a kind of short notes for you. You should also make a similar kind of these notes, because eventually it will help you in your revision. So yeah, as we saw that velocity had we found two kind of velocity, which were the its average velocity, which was V average, what it was changed in its position with time, and instantaneous velocity, which was this, right? Similarly, acceleration was average acceleration, and instantaneous acceleration. So this will be like the short notes for you, and obviously while you would be revising, then you will only need to revise this mind map. Now coming ahead, now we need to see the motion in the straight line, right? Suppose body is moving with constant acceleration. That means, first thing, what does it mean, the constant acceleration? See, as we have seen that acceleration is what? The rate of increase in the velocity with time, right? So if there is constant acceleration, which means if I would take this particular interval when body is moving from point A to point B, if I would take this particular interval, say t1 time, and I would take same kind of interval if the time is same t1, and similarly anywhere if I would consider the same time difference for any two intervals, then if the rate of if the acceleration would be same for this interval, for this interval, that means the rate by which velocity is increasing for this particular interval is the same as the rate the velocity is increasing for this particular interval, right? Let's say here body has velocity v1, body has velocity v2, v3, and it has v4. So what it would mean that if body would have constant acceleration, then this v2 minus v1 upon this time interval, say delta t1, it would be equal to v3. So this would be what? This would be termed as a constant acceleration, right? Say body is moving with constant acceleration and body is moving in a straight line. Body is moving with constant acceleration. Remember these two terms, these are very imperative or important. One thing, body is moving with in a straight line, and secondly constant acceleration, right? Straight line motion, like body is only moving in a straight line. It could be like this horizontal line, or it could be like this vertical line, or it could be like any oblique line. So if body is moving like this way, or body is taking this kind of trajectory, then motion is called as straight line motion. And a second requirement is that body should have constant acceleration. I have told you the meaning of constant acceleration. If body has constant acceleration and moving in a straight line, then what can we find, or what could be the phenomena which would be acting on this? And if we want to find its initial velocity or final velocity, or its acceleration, or the total distance it would have covered, or say we need to find the position of this body at any particular time here, how we can find that? Or uh, like whether this would be applicable for the motion which would be happening in the plane or not, that we also see in this lecture. So first thing is this that we need to find its velocity initial, final, and secondary acceleration and distance, or the position of particle, right? So finding these things will gives us the equations of motion, right? So these are very basic and very important for solving the problems. You should remember these mainly equations of motion, right? So let us derive these three equations of motion one by one, and then you only need to remember the final formulas which should be coming here after solving those equations. Although you can also remember this process which are asked generally in the boards. So yeah, as body is moving with constant acceleration, and I have told you what is the instantaneous acceleration. Instantaneous acceleration is this, right? So I'm going to use integration. If you know how to integrate something, although it would be very basic integration, so if you are not much aware about the integration, so you may be aware in due course of time, but here it is very basic integration you should be aware of, right? So from here velocity would be what? ADT, right? Now I'm going to integrate this. From differentiation, integration will get cancelled out. Or if I will have to use the limits, then what will I can do? Say at time t is equal to 0, right? At time t is equal to 0, body was moving with velocity u. It was its initial velocity. And at time t is equal to t1, body had its velocity v, right? So from here, what will I get? I will get this is very basic thing you may be aware about, that final upper limit minus lower limit, how should I have to integrate, right? So yeah, it would be v minus u, which will be equal to a t minus 0, right? So it will be what? At. From here, what is v is equal to u plus at. So this is our first equation of motion, right? What is v is final velocity, and what is u is initial velocity, and obviously acceleration, which is constant. So this is our first equation of motion. You should remember this thing. This is what v is equal to u plus at. I'm going to use this thing in the problems that I have brought for you. So yeah, secondly, as we have already derived that v is equal to, now I have told you what is velocity. Velocity is the change in the distance with time, right? Or you can say dr upon dt, but here I only require to write the x component, since I am considering that motion is along x-axis, so only x is changing. So what it would be? It would be dx upon dt. What it would be? It would be u plus at. Again I am going to integrate this. It would be dx, which will be equal to u plus at dt. Integrate. Now say at time t is equal to 0, body was at rest, and its displacement, or what you can say, the position was 0, right? Position was 0 means it was at origin, right? It doesn't mean that particle would have 0 position. It doesn't make any sense. Position 0 means it is at the origin. Its coordinates are 0 comma 0 comma 0, right? And at time t1, it would be say at x. From here will be equal to what? 0 to, I can simply write 0. will be what? Now again integrate this thing, it will be what? U dt plus at. Again what it would be? It would be ut plus, by solving this integration, what I have got x, which is the position of particle. Remember, it is the position of particle at that particular time. It is not the distance that body would have covered, it is the position. It is ut. So this is our second equation of motion. What it gives us? It gives us the position of particle, and it is its initial velocity. What it is? It is initial velocity, and it is acceleration, and it is the time at where I would be interested in finding the position, right? So yeah, this was our second equation of motion. Now since I do not have much space, so I have to erase it from here. Yeah, so firstly we determined that first equation of motion, which was, and second was, right, this was equation 1, this was equation 2. Now if I will square the equation 1, then what will I get? Whole square, right? Now solve this whole square. Okay, so from here I can take a and t common, and what will I be left with? I will be left with at plus u, right? Here I am also taking 2 common. If I will take 2 common, so here I will have to divide with 2, right? So from here, see, here is t actually. So from here, what is it? It is the x, right? I'm also, yeah, this is x. So this is our third equation of motion. What it is? Right, so these are our three important equation of motion, which we will be just using in the problems. So what these are? These are, and obviously this. Remember, when you can use these, you can use these equation when there is constant acceleration, and secondly motion is in the straight line. If motion is in the plane, then you cannot use these things. You need to take the component of these equations, which obviously I will tell you how you will have to make the component of this thing. But remember, if there is constant acceleration, you can only use these things. Now this was for motion which was happening uh, in the straight line, right? So as we have derived these equations, so let us fill the our mind map which we had made. So we had three equations which were, these concepts back. So now we need to look into the motion in the plane. What will happen when motion will be happening in the plane, right? So I'm going to write here. Yeah. So okay. Uh, Firstly, we need to understand what is the plane. As like earlier, motion was happening in the straight line only, so only one axis was undergoing into a change. That could have been x-axis, that could have been y-axis, or that could have been z-axis. uh, Say this was our frame of reference, so motion was happening in the straight line only. Here only x was changing as particle was moving on x-axis, or it could have been moving on y-axis, so only y-axis would have been going into change. If it would have been moving under this kind of line, then only this z-axis would have been undergoing into a change, right? This was the motion in the straight line. And now I am going to consider the plane. What is plane? Plane is something which is made by two axes. Sorry. So this is x, this is y. So this is x. If body will move in a such a way that its x-axis only right. So see here, because two axes are changing and motion is in the plane, then I also need to take its y component. As here it could have its two component. If you may be aware that how to resolve any particular body in its component, this is like studied in the basic physics or basic vectors. If you know how to resolve the vectors, if you don't know, you can comment, I will make the video on that. But for like, just let me quickly tell you. Say body is moving like this and it is making an angle theta with x-axis, so it would have its two component. It would have its x component and it would have its y component. The component along x-axis, from here it would be uh, cos theta, and component along y-axis would be sin theta, because it would be 90 minus theta, and this will gives us the sin theta. So from here it would have its two components. Say it is moving with velocity v, then this velocity would have two components. What would first would have been v cos theta along x-axis, and second would have been the uh, sin theta along y-axis. So we can simply write these things as v y. x component, and in the it's y component. So yeah, we need to write the motion along x-axis and along the y-axis. From here, if I will write along x-axis, so I would be taking the component along x-axis, right? So first equation would be Vx, which is the final velocity along x-axis, which is equal to the initial velocity along x-axis and acceleration along x-axis. Second is x, which is equal to uxt plus axt square. And thirdly, uh, this velocity. Secondly, the students ask that when we can use which of this equation. You can use any one of this equation for finding anything which should have been asked in the problem. So according to the problem, you can use any kind of this thing which should be suitable for that problem. For example, if you need to find the velocity but you have not given the time, so you can use this equation. That is not so. Would be this because you this equation is the direct function of time, as you can see here, and obviously you can find the position at any particular time. So according to problem, you can use any one of this equation, right? So secondly, I would have to write the motion along y-axis. It would simply would have what vy uh, and third thing is vy square uy and 2ay. So this is how these equation will undergo into a modification, and you can find any one of this thing like velocity, acceleration, or time, whatever will be asked to you in that problem. So this equation will be only for plane motion. Yeah. So for plane, one of the finest example is the projectile motion. But first fill these things. Here write down these all equations along x-axis and take component along y-axis as I have done, right? So now the third thing which I would have to cover, that is the projectile motion. This is one of the important thing, and you should be aware about the all the phenomena which would be happening in the projectile. So all these kind of things only would be happening in the projectile, nothing new. So let me erase this. Yeah. Firstly, write down these all three equations. So we want to study the projectile motion. What does it See, when our body moves like this, this motion is called as projectile motion, and the angle which it makes with x-axis is called as angle of projection, right? And what we need to find in the projectile motion, there are few things that we have to find. Well, first is the motion along x and along y. Second thing would be its time of flight. Thirdly, its range. What these things means, I will tell you. And fourth thing is the maximum height it would attain. Right, these are the things that we need to find for any projectile, and your maximum of work will be get done just by knowing these things, right? So first thing is the motion along x or y axis. But let me tell you, say if this is point O and this is point A, right? So the total horizontal distance that it would cover would be termed its range. That will be its range, right? And the time that it will take to cover, it will take to cover this whole of the distance O to, this will be its time of flight, right? And the maximum height that it which is equal to, right? Now third thing is the velocity. Say this body has a speed of what, which is v, like, right? So along x-axis and along y-axis I need to resolve this speed, and this will be termed as velocity because it would have direction. So along x-axis what its this velocity would be, that would be what? That would be u is equal to v. Sorry, let me write in new slide. Yeah, it has velocity v, and we need to resolve this velocity along x-axis and along y-axis. The x component of this velocity would be initial velocity. I'm taking the initial velocity, that would be u cos theta along x-axis, and along y, that would be u sin theta. Now here we have found what? It would be equation 1, it would be equation 2. We have found the position of this body at any particular time along x-axis and along y-axis. So let me write again this thing by segregating like whole of these things. Along x-axis I'm going to write whole of these things, right? First thing, we found the position at any particular instant t, which was ut. From here u is what? U is cos theta, right? From here x is equal to u cos theta. Remember this thing. I'm going to give it equation 3. And if I will find the velocity, now I want to find the final velocity. As it is the initial velocity, I want to find final velocity. I will use this equation, equation 1, right? So what is the equation 1? I mean first equation of motion, that is v is equal to u plus at. Along x-axis, a is equal to 0, right, and u is equal to u cos theta. So what would be the final velocity? Final velocity along x-axis, that would be vx u cos theta. That will be what? Final velocity along x-axis. Let me term it equation 4, right? Similarly, I'm going to find the motion along y-axis. Okay, so along y-axis, firstly we have found that what is y? Y is equal to this. Right, so put this value of u sin theta. I am assuming that you know how to resolve these components, right? By resolving the components of velocity, I am getting this u cos theta and u sin theta. Otherwise I will make a separate video on resolving this component of any particular vector, right? So y is equal to what? U sin theta times t minus 1 upon 2 gt square, right? This would be position of this projectile at any particular time in y-axis, right? Along y, I can find the position anywhere, anytime, because it is the function of time. Third thing is velocity along y-axis. Again, I will use the same formula along y. That would be what? Vy uy plus at. It will be equal to what? Yeah, what is ui? Ui is u sin theta. And what is acceleration? Acceleration minus g times t. So this is the velocity along y-axis. What it is? This is final velocity. Actually, vy is equal to u sin theta. U is initial velocity So this is the final velocity along y direction, and this is the final velocity along x direction. Let me highlight this thing. This is final velocity along x direction, and this is the position at any particular time. Oh sorry, here is t. I missed this t. And this is position along y-axis at any particular time, and this is velocity along y-axis at any particular time, right? So these four equations you should know. Secondly, as I told you, I am going to find the time of flight, range, and its maximum height. But first you should know these four equations. This was x, y, and ux and uy, vx and uvy, sorry. Yeah, so as we saw, what motion of projectile along x-axis and along y-axis. Along x-axis we found x, we found what, vx. Similarly along y-axis also we knew ax, which was 0, and similarly along y-axis we found y, we found vx, and we knew ay, which was minus g, right? Acceleration. So now we need to find certain things, which are, number one is time of flight, and second is the range, third is what, the maximum height it would attain. Okay, so as this is the projectile, right, this is angle which is called as angle of projection, and say this is a, this is point b, position b. So total horizontal distance it would cover uh, from point a to point b, that would be its range, and total time it will take to cover this whole this whole trajectory or path, that would be its time of flight, right? So see here at point b, what is happening, it will only have its y x component, right, because it is at x axis. So its y component would be 0 at this point, at this b point its y component would be 0. That means we only have x, which is equal to u cos theta t, and we only have its horizontal velocity that we have found, right? And we will have what, its y component, and that would be 0, right? Because at particular time b its y component is 0 and it has already traveled this whole trajectory. Then what we can write, we can write y, what is y component at this particular point, which is 0. Then we would only have this thing, right? Put the value of this uy and ay. Uy was what, u sin theta time t plus, sorry, mine right like this, minus g time t square is equal to 0. Simplify this equation, what we would have, u sin theta times t is equal to 1 upon 2 gt square. From this it got cancelled, and I have time, which is t. Remember this thing, this is very important. This is the time of flight, 2 sine theta upon g. The total time this particle will take to cover this whole trajectory to reach point B will be its time of flight, and that time of flight is this. This is what the time of flight. This is the time of flight, right? Now I want to find its horizontal range. Horizontal range is what? Horizontal range is total distance it would uh, cover horizontally from point A to point B, right? How much that would be? That would be found from equation this. Because horizontal distance it is covering on x-axis. That is why I am taking this x-axis. Otherwise, I would have taken y-axis, right? We know along x-axis its acceleration is 0. Then x is equal to what? U xt, and we know what is u xt. What is ux? We know that is u cos theta times t. So from here x is equal to u cos theta times t. T is what? T is the time of flight. Why? Because reaching this point B, it has taken this this much of time which we have just determined is that was time of flight. So this time of flight is actually this time. So we need to put the value of this time of flight here in this equation. From here, this will be what? U cos theta and 2u sin theta upon g, right? Just simplify this. Oh, what we had x is equal to u cos theta times t, and after putting the value of time we had, right? So simplify this thing, it will become and use very basic formula of trigonometry. So we will have its range. This is what the range of this parabola, sorry, this projectile. Why only x component? Why only along x-axis? Because we are considering that projectile is moving along what? Along x-axis. If motion would have been like this, then here we would have been taking the y-axis, yeah, y-axis, and here for finding the time of flight we would have considered x is equal to 0. So this is how we can find the range and its time of flight, right? So thirdly, we need to find the maximum height that this projectile would attain. Okay, we need to find the h max. What is the maximum height of this projectile? This maximum height, and this is the maximum height of this projectile, right? See here at this point, at maximum height it only has its horizontal velocity. It does not have any component along y. You can like readily see here that there is no component of velocity along y, because now it is starting falling downward. It has started falling downward like this way. So here it may have its vertical component, because it would be like this. It is because it is moving like this, so it would have its vertical component and it would have its horizontal component at this particular situation, at this particular situation, or at this particular situation. But at this particular situation where height is maximum, there is no component along y-axis. There is only and only component along x-axis, right? So from here we can write that Vx is equal to, and Vy Because along y-axis there is no component of velocity, therefore uy will be equal to at, because it will be 0 and by it will come here this side and this will, I mean 0 is equal to uy plus a plus at, and it will be g, because along y direction what is the acceleration, that is g, it will be uy minus gt, so it will become this, right? So from here time, this is the time at maximum height, that means the total time this body will or this projectile will take to reach from here to here, it is not time of light, this is time taken to reach maximum height, that will be what, uy upon g, right? This is the time body will take to reach maximum height. I am repeating again and again because this is very important. That will be u sine theta. Why? Because we have like already resolved it into a two component, which is u sine theta. So the time which it has taken to reach the maximum point is this u sine theta upon g, right? Now I want to find what the maximum height. Maximum height I can find by second equation of motion, which is for finding the position at any particular time, as I have already told you many times. So similarly, now because I am interested in finding the maximum height, therefore it will be along y, right? What is the time that body will take to reach the maximum height? That is this we just found, right? So put this time in this equation. Uy is already u sine theta and t is what, u sine theta upon g minus 1 upon 2 g into u sine theta upon g whole square, right? So just simplify this, you will get maximum height that this body will attain, which would be u square sine square theta upon 2g. So this is the maximum height that this body will attain, that this body will attain, right? So remember we had four important equations. Let me further try to highlight it with different colors. So this is the range of body. The range is 2 u square sine 2 theta upon g, and this is what the maximum height that body would attain, that projectile would attain, and this time that this projectile will take to reach the maximum height. And one important thing is the time of light. This is time of light, that was time to reach it was time to reach maximum height, right? So let us put these formulas in this uh, mind map. So what we did just few things. What first was our motion along x and along y. Second thing was time of light, right? Third thing was range, and fourth thing was time that it has taken to reach the maximum height, right? And lastly we found what, we found the maximum height. Just write the formula of this thing here. Why I am making this thing? Just because it will help you in the revision. So along x we saw what, we saw acceleration was 0 and x was equal to what, u cos theta times this t. right? And what was Vx? Vx was simply u cos theta. This was along x-axis, and along y we had our y. Ay was minus tan g. What was y? Mm, this was y, and what was our final velocity, which was uh, this is actually minus. This was motion along y, right? Then we found the time of flight. What was the time of flight? T. That was 2u sine theta upon g. And what was the range? Range was, let's say, d. That was what? Let me check. This was our range. 2u square sine 2 theta upon g. 2u square sine 2 theta upon g. 2u square sine 2 theta upon g, right? And was u square sine square theta upon 2g. This was our like basics of this projectile motion. So this will help you to consolidate these topics. You can further highlight this thing, right? So now lastly we need to see the transformation. Okay, transformation from one frame of reference to another frame of reference. Okay, let me add few slides. Okay, yeah, so last thing is the transformation. Yeah, so as you know what is the frame of reference. Frame of reference is something from where we designate some coordinates to any particular events which should be happening at any particular time, and then we try to find its location or its velocity, acceleration, anything like this, right? This is x, this is y, this is z, and this is my origin, right? So you may be aware that there are two kind of frame of reference. One is internal and another thing is external, or these are also so here I'm just going to consider the inertial frame of references, not the non-inertial frame of references. The non-inertial frame of references will be discussed in Newton's law of motion in just upcoming 3 or 4 lectures. Consider these inertial. or moving with velocity with respect at rest at any particular time, right? This is any frame of reference s dash, right? And this there is one another frame of us, anyone who is playing, and here are you, and here is your friend, right? So the wisdom of you, I mean your wisdom and your friend's wisdom would be termed as the frame of reference. How you both will be looking at these boys, like how these are playing. So this should be termed as their frame of reference. Now I am saying that yeah, this who is your friend? He is moving with velocity v with respect to you, right? With respect to you means uh, say it has velocity 3 meter per second with respect to you. Say this body is also moving with velocity 2 meter per second in the same direction. So can I say that uh, your friend would also have velocity of 3 meter per second with respect to this boy? No, I cannot say that because velocity is relative. That is why I'm saying that velocity with respect to someone. So if I am saying that velocity with respect to you is 3 meter per second, so obviously its velocity with respect to this moving man would not be the 3 meter per second. It would be relative velocity. It would be like found from this formula, as you may be aware of this, right? So similarly, I need to find what the velocity of this particular frame or this particular event, how this event would be seen from this wisdom, or like how this event would be seen by uh, this man. Say this is X, right? So this is actually what these frame of references in simple term means. So coming back to here, right? So if I know that uh, let's say velocity of this body in frame S is v1 and velocity of this body I want to find in S frame, then how I can find that velocity? As we know, this is the position vector of this frame from this S dash, right? So if I want to find the position velocity of this particular event in this frame which is moving with velocity v, and I know velocity of this event in this frame, then what I can write, this is the transformation equation, which means velocity of this particular event or particular particle p in this S frame is equal to velocity of this particle p in S dash frame plus the velocity of this S dash frame in the S frame of reference, right? From here, I can find the velocity of this particle in S dash frame. That would be what? Velocity of particle in this frame would be minus vs dash, right? So this is how high. This is how I can find the motion in two frame of references. Actually, these are called as the Gaussian transform, right? And if this event is moving with velocity of light, then this will be modified to Lorentz transform, which should be discussed in the special theory of relativity, right? So this is like the basic transformation of equation of motions, because here you also have to consider the cause its component, which should be cos theta and sin theta. So this is how you can transform your motion like velocity, acceleration, or your position vector from one frame of reference to another frame of reference, which mean if any event is happening, how this event would be seen by an object which is moving with velocity v, right? If I know that event has velocity something in frame S, then how I can find the velocity in frame S dash? So this is how these things mean. This is like you need to imagine that how you can find this thing, like how this thing would be happening. This is moreover your imagination. Only then you can comprehend this thing, whether you have received this thing or not, right? So this was only like the theory part of the kinematics, and more or less in maximum courses only this much of theory is being taught. And now we will move to question solving, which is very important part of this video. So what was the transformation equation? That was velocity of particle in any rest frame was equal to velocity of particle in the moving frame plus velocity of that moving frame in the stationary frame. So this was our the whole theory part that has got covered. Now we will be solving the questions, or let me see whether I should make the separate video for solving the question. The separate video for solving the question, as video has already got long, so I'll be making the separate video for solving the question, or you can try first from your side that how these questions will be solved. Yeah, I'll open all these questions one by one, then I will be discussing these all questions in the next video. You can see the question here, you can pause the video and solve these questions, and this thorough solution of these questions will be discussed later on. These are basics question, by the way. Yeah, right. And this is the question asked in the JEE advanced exam. And yeah, this question also you should give it a try. Yeah, this question was